Now this is called your forward pass. Again, when you have two arrows coming into any activity, you must use the larger of the two. Now what I'm going to show you is the backward pass. Now when I do the backward pass now, what I'm going to do, I'm going to change the color. Very important. This will allow you not to make mistakes if you use another. The mind will automatically pick the color that you are using. So now I'm going to use green. Now in green, now I'm going to just label it here. Backward pass. Okay. I may have to just do this adjustment here. I wanted a green marker. Should have checked the green was working first. Okay. Yeah? Okay, no problem. Okay, so in the backward pass, now I'm going to use in green. Now, how the backward pass works. We go now alphabetically backwards. The last activity is J. We are dealing now this way. We have to go backward pass goes this way. But you have to start at the last activity. So, what is the latest finish for J that would still allow the project to finish on the 28th day? The latest finish for J would be what is coming from here, 28. That is the latest finish time for J that the project could still be completed on the 28th day. So, now we go backwards, right? So 28 minus 4 would give us then the latest start, which is 24. Now we go backwards. So it's J and I. So we look now on the right hand side of I. Where is I going to? J. What is the latest finish time for I? Since it's coming only from J, it will be 4. Only one arrow coming out the right hand side. So it means that we pick this value would come here. It's the latest finish time would be equivalent to the latest start of the next activity. So we go backwards now. 24 minus 4, 20. We go now to H. Now in H now is again only 20 here. 20 minus 8, 12. G now. G is coming from J. So the latest start becomes now here the latest finish, 24. 24 minus 3, 21. And let's go F. Where's F going to? F is going to the end, so 28 has to come here. 28 minus 4 is 24. Let's go to E. Now E only goes here, so 21 comes here. 21 minus 6 is 15. My maths is good. Now we come D. D is going to G, so D is 21. 21 minus 10 is 11. Now we have what else? D, then this C. Now notice now C has two values. C has, on the right hand side now we look, there are two arrows coming out of C. One value is going to 11 and one is 24. The rule now is for the backward pass, you pick the minimum value, the smallest value. In the forward pass, we chose the maximum. In the backward pass, we choose the minimum. What is the minimum value of these two? 11. This is the latest finish time for C, which will still allow the project to happen on the 28 days. If I had this finishing at 24, then it would throw off the whole schedule. So the whole concept is that you still want to finish in the 28 days, But this calculation in the backward pass is saying, okay, what is the latest finish time? The latest finish that will still allow the project to finish on the 28th day. In this case here, you have to pick the minimum of the two values, which in this case is 11. 11 minus 3, 8. Now, we come to B. Again, B has two values. B has 12 and 15. The smallest of the two values is 12. 12 minus 6 is 6. Now we come to A now. A again has now two values coming into it, 6 and 8. So we pick the smallest value, 6. 6 minus 6, 0. That's very important. If, for instance, this arrow was coming from the top or the bottom, you might have missed that this activity was also involved. Or let's say, for instance, with this activity. Suppose I had this activity coming from this part. What might have happened was, when I'm looking at the right hand side, I only see one arrow. In this case, I would have been okay because I would have chosen 11. But if this was the larger of the values, I would have missed the smaller value. So it's very important, very, very important that you make sure that all your arrows come from the right hand side. Okay? Now, we have just calculated what is called you just calculated the backward pass. Now there's one more thing we still need to calculate, and that calculation is the slack time. Now the slack time is very easy to calculate. Very easy to calculate. I remember it always this way, is the bottom minus the top. In this case, it's the latest finish minus the earliest finish, or the latest start minus the earliest start. But the bottom minus the top. Okay, let's start here. We'll do the latest finish and minus the earliest finish for the slack. 6 minus 6, 0. B, 12 minus 12, 0. C, 11 minus 9, 2. D, 21 minus 19, 2. 21 minus 18, 3. 20 minus 20, 0. 28 minus 13, 15. 24 minus 22, 2. 24 minus 24, 0. 28 minus 28, 0. Now we have calculated the slack time. Okay? So the question that we were asked to do was construct the PERT network for this problem. This is the PERT diagram. What are the critical path activities, which was question number, part B of that question, which we're now going to show you how to calculate. The critical path activities. Now, after going through, we've done all the calculations within the table. So now answering these, question number B and C, will be very easy because all the information is already in the table. Using this technique, we're able to get all the information very quickly. Now, it says, what are the critical path activities? Now, critical path activities are those activities which have a slack of 0. That means no slack. But how you have to work it out is, it's like you have to map the path from start to end. So in this case here, we're going to map the path. Now we start from start. Which activity has 0 slack from start? There's only one activity coming out and it has a 0 slack, which is A. Now, A goes to B and C. Now, going along this path, which one has a 0 slack? B would have it. So, we come A, B. From B now, it goes to 2. It goes to H and E. But which one has a 0 slack? H. From H now, H goes straight into I goes straight into J goes straight into N. So in this case here, our critical path, let me write it here, our critical path is A, B, H, I, J. That's our critical path. Now, again, we follow the path from start to end, using only those activities that have zero slack. So coming from start, the activity that has zero slack is A. Now when we come to B now, or when we come to next step, we realize that from A goes to C and B. But only B has the zero slack. So we go A to B. Now B goes to H and E, but E doesn't have any slack. H has the slack. Sorry, has no slack. So in this case, it will be A, B, H, I, J. Now it is possible sometimes to have more than one critical path in a project. In that case, if you came to this point here, we went A and it went to B. B was 0 and C was also 0. What you would have to do is start from A, go B, follow that path all the way to the end. That would be one critical path. Come back again, start again, but then instead of following the B path, then you would say, okay, look, follow the A, then follow the C, because if C also had 0, then you follow that path. That is for projects that have more than one critical path. You have to then rework it from beginning to end, the second critical path. In this case here, we only have one critical path, which is A, B, H, I, and J. Yeah. So this now brings you to question number B. Question asks, what are the critical path activities? Your critical path activities is the A, B, H, I, and J. It asks you now, what is the expected time to complete the project? Well, this we had worked out before. The expected time to complete the project is 28 days. Okay. Now this is the most important part of this question. Now the next step, which I'll show you afterwards, is how to work out the probability. The next question talks about, given that the variance of the project is 9.1, what is the probability of the project being completed in 27 days? That part now is a different calculation, but once you have this part done, you have majority of the work done. The next part I will show you in a few minutes.